All right, folks, back in action here. On this page of notes, we're going to start evaluating some of our logarithms. It's going to create a foundation for us to do our solving later in the chapter. So the first thing that we need to look at are two basic rules: the log of 1 when we evaluate logs of 1, and when we evaluate logs where the base of the log and what we're evaluating are the same. So our first rule, log of 1 will always equal 0. And when the base of the log matches the argument of the log, that will always equal 1. Log base b of b will always be 1. So on these first couple examples here, I just want to get a better understanding as to why these rules are true. Makes it a little easier to understand them. So on our first one here, we have 5 to the 0 power equals 1. Now we understand this to be true. So if we convert this to our logarithm, we can understand the new rule. So we can draw this little circle like I did in the previous video to help us remember how to rewrite. So we'll have log base 5 of 1 equals 0. So that's exactly what our rule said was going to happen. The log of 1 is 0. That's exactly what this told us right here. Now, if I want to think in the other direction, for example, log base 8 of 1 equals what? We understand from our rule that this should be 0, but let's do a little converting to understand why it actually works out. So again, we're going to convert, this time in the other direction. So what we would have is 8 to the x power equals 1. Well, what we're going to do is we're going to think about, if this is 8 to the x and we want these to be equal, then on the right-hand side, I need to write 8 to some power so that this would be a true statement. The only exponent that I can put in here so that this would be a true statement on each side would be an exponent of 0. Thus, we can simply conclude that our x must be 0. So it's another way of saying and understanding that our log of 1 should be 0. Now, on this other side, we can take a look at our other rule. Our log base b of b should equal 1. So again, let's do a little converting to our logarithmic form. We can clearly understand that 5 to the first power equals 5. So if we do our conversion, we'll see log base 5 of 5 equals 1. So there's our rule. We can see the base of the log, the argument of the log are the same, and that evaluates to 1. Now what we can also see this as is we can also imagine the exponent of 1 drawn in there, and that helps us see the equivalency of 1 a little bit better there. So now we can convert the other way, just like we did on the other problem. We know that log base 8 of 8 should be 1, but let's get a little better understanding why that is actually 1. So we'll convert again. So I like to draw that little circle. So I have 8 to the x power equals 8. So just like we did on part B, we want to think what exponent should go in there. So it should be a true statement. And of course, 1 is the only thing that would go in there to make it true. So of course, our x value has to equal 1. Okay, now using those ideas, we can evaluate some more complicated looking things. So just reiterate our rules. The more we write them, easier it is to remember. So the log of 1 will always be 0. Log base b of b always equals 1. So now, when I'm asked to evaluate something like this, specifically, and this is important, without a calculator, on this section of the test, you won't have a calculator at all. So let's take a look and see what I could do. Now, we generally don't want to take expressions and turn them into equations because that kind of muddies the water. So what we're going to do in this case is I am going to put an equals here, but I'm going to write a little ANS for answer. It's going to help me keep track a little bit better of what I'm doing. I never want to put a variable in there because sometimes there might be a variable in the problem already and it definitely complicates it. For example, on part C, I can see I have an x in the exponent, and on part D, I have an x in the exponent. So we're going to write this little ANS. Now let's convert to exponential form because we're already pretty comfortable with exponentials. So if we convert to our exponential, what we'll end up with is 3 to this exponent of what I'll call answer equals 1 over 27. Now, what I'm going to do is I'm going to take this right-hand side, I'm going to get rid of this fraction, and I'm going to rewrite this with a base of 3. So what I can do is I can write this as 3 to the ANS equals, now 1 over 27 is going to be 3 to the negative 3. Now, if this is a true statement, if the bases are the same, then these exponents should be equivalent as well. So we can say that our answer, what we knew we wanted to evaluate this to, is negative 3. So let's take a look at another one. There is, by the way, a faster way to do some of these as you get a little experience. I can show you some quicker ways to do these. We'll probably cover those in class, but for the sake of the video, this is a good place for us to just leave our discussion. So I'm going to set that equal to the answer. Then I'm going to convert to my exponential. So I'm going to say 1/2 to the ANS for my answer equals 32. The goal is to write each of these with the same base. So I'm going to, of course, write this as 2, and I'm going to put a negative answer because 1 over 2 is 2 to the negative 1. And 32 can be written as 2 to the 5th. Again, if the bases are the same and this is a true statement, then the exponents should be equal as well. So I can say negative answer equals 5. Thus, my answer is a negative 5. All right, let's go on up to part B or part C. Now, this one looks a little bit more complicated because it has this natural log. So we're going to do a couple things on this one. I'm still going to set it equal to my answer, but I'm going to rewrite this. Instead of the natural log, I'm going to write it in the longer notation, log base e, instead of this ln right here. So the ln becomes the log base e. Then I'll still have my e to the x plus 12 equals my answer. I'm going to convert now to my exponential form. So I'll have e to the answer equals e to the x plus 12. Now this problem looks pretty simple. My bases match, so my exponents must be equal. So my answer is x plus 12. And there isn't anything more to solve on this. That is the answer. That's the beauty of this particular notation. One more here. This one, you can see that I don't have the base of the logarithm written in, which means this has to be a natural log. So if you want, you can write this ANS right away. But remember, this log, since there is no base there, needs to be rewritten as log base 10 of, I'm going to write this 100, x plus 2 equals the answer. I'm going to convert this. So I'll have 10 to the answer equals 100 to the x plus 2. Now I need to get these bases to match, so I'll have 10 to the answer still. And 100 can be written as 10 squared. And then, of course, these exponents will multiply. So my final answer is 2 times x plus 2. No need to distribute, no need to try to solve for anything. That's all that we've got on that. We're going to practice a lot more with these, so if you are hesitant at all, you can work on converting between the two forms and also just reviewing some of your basic powers that we did on the skills review in class.